So let's look at some examples of how we use cross-section, because they're on every AP exam and they're really not that difficult. You had this problem on another part of volumes, but I'm just taking the part that has to do with cross-section. So this is a sketch of a region. I've already drawn the little cross-section in there, so before it was just that region. And f of x is 1 plus x plus e x squared minus 2x, and g of x is x to the fourth minus 6.5x squared plus 6x plus 2. And it says region S is the base of a solid whose cross-section is perpendicular to the x-axis and are squares. Find the volume of the solid. So if it's perpendicular to the x-axis, it means you're going to use x bounds. So the first thing you want to do is put it in your calculator and find this intersecting point. So if you do that, it's this number. Okay, and then what you want to do is figure out what the side of your square. So that was the base, and then it went up, if you think dimensional. So the side goes from this top function to the bottom function. So therefore your side is represented by 1 plus x plus e, x minus 2x, minus your other function. And then what is the area of a square? It's s squared. So then how do you find your final area? You just integrate from the 1.03 to 2, and you do your side, which is this minus this squared dx. So that whole thing is squared because it's the side, and you get this figure, 1.283. So our next example, we have this little region that's bounded by these two functions, x to the fourth minus 2.3 x cubed plus 4 and y equal 4. And it says region R is the base of a solid. Each cross-section is an isosceles right triangle with a leg in R. Find the volume. So you draw this and then draw your triangle going up. So the base of the triangle or the leg of the triangle is this. So I want to find my intersection point. I've already got it labeled, but the problem originally didn't have it, so you had to get the intersection in the calculator. So 0, 0, and 2.34. Now, what is my base? What is the length here? It's 4, which is y equal 4, minus my other function. That gives me this length. Now, the area of an isosceles triangle, you know, a regular triangle is 1/2 base times height. But because it's a right triangle, the area is s squared divided by 2. And when you get closer to the exam, you're going to have some formula sheets to memorize, and that's one you want to memorize. So then all I have to do, get where you can see this, is I'm going from 0 to 2.3. I've got my side squared divided by 2, put it in Math 9, and I get 3.574. So this next one, we have this shape. It's bounded by these two functions, and it says region R is the base of a solid where each cross-section is perpendicular to the x-axis is a square. Write but do not evaluate an integral expression that gives you the volume. So again, you're going to make your base of your square and come up. So again, the area of a square is s squared. So what is my length? It's my top curve minus my bottom curve, which is this. So when I set up the integral, I'm just going to go from 0 to 2, and I've got to square this. So I'm going to go from 0 to 2, because those are x bounds. My top curve minus my bottom curve is my side, and then it's squared dx. So our next example has it going like this, little shape, and it's bounded by the square root of x, 6 minus x, and the x-axis. And it says region R is the base of a solid for each y from 0 to 2, the cross-section of the solid taken perpendicular to the y-axis, so this is different, it's a y-axis, is a rectangle, whose base is in R and whose height is 2y. Write but do not evaluate the integral for the volume. So my base went from here to here, and then I made my rectangle going up. So what is the length of my base? Well, since it's y bounds, we're going right to left. So when we do our base, we've got 6 minus y squared. And then we have the height is 2y. So when we do our integral, it'll just be from 0 to 2, 2y times 6 minus y squared dy. I forgot to say in this one, because it's y bounds, you have to convert your x equal equation to y equation, so that's where those came from. You can see up here. Now our next example has a little triangle shape. It's bounded by y equal 2 square root of x, y equals 6 in the y-axis. And it says region R is the base of a solid for each y from 0 to 6. The cross-section of a solid taken perpendicular to the y-axis, so that tells you you're doing y bounds, is a rectangle whose height is 3 times the length of the base. Write but do not evaluate. So my base is going to go from here to here. So because we're doing y bounds, we have to change our y equal equations to x equals. So if you do that, you're going to get y squared over 4. So your base is y squared over 4. Your height is 3 times that. So your area of a rectangle is this times this, which if you do that, you get 3 times y squared over 4 squared. So then your integral will just go from 0 to 6.